In this video, we're going to be doing a review of the exponents from Module 3. So you can see here in this box, we have all of the rules for the exponents. So anything to the 0 power is 1. If it just says a, it's a to the first power. When we are multiplying with the same base, so remember that a to the m, a is your base, and m is your exponent, right? So when I say base and exponent, that's what I'm talking about. M is your exponent, right? And then the definition of a exponent, right? So if I had a cubed, is that a times a times a, right? That's what it means. It means itself times itself, however number the exponent says, however many numbers the exponent says. So when you have the same base and multiplication in between, we do m plus n. Division is minus. If it's negative, you move it across the division bar. So if it's already on the top, you move it to the bottom. If it's on the bottom, you move it to the top. A power raised to a power gives you a to the m times n. And then ab to the n, you distribute it in. Same for division. And same for a negative, you would distribute it and then move it. Right? So these rules build on each other. And you do have the ability that as long as you can remember this, okay? As long as you can remember the definition, you can actually figure these rules out. So if I had a squared times a cubed, right? If I use the definition, a squared means a times a times a cubed is a times a times a. Well, how many a's do I have now? 1, 2, 3, 4, 5. A to the 5th, because when you have multiplication, we add exponents. So we get a to the 5th. So see how I just used the definition to actually find the answer. Now you're not going to want to do this on every single one, but if you're confused and you're like, I'm not sure what I'm supposed to do, you can very easily and quickly figure out what the rule is. The same thing applies for division, right? If you had a to the 5th over a cubed, right? A to the 5th is a times a times a times a times a divided by a times a times a. Well, anything over itself equals 1. So 1, 2, 3 cancel. I'm left with a squared, or a to the 5 minus 3, which gives me a squared. So you can actually figure these rules out, and you can do this for all of them, except for the negatives. You just have to kind of memorize the negatives. You're able to figure these rules out. So if you're on the test and you're panicking. Okay, so now let's try some examples. Simplify the expression, write the result using positive exponents only, which is generally what my math lab asks for. So please be aware of that, positive exponents only. And this says negative 5 to the 0. Hopefully you're saying, oh, 0 power equals 1, right? Something to the 0 power equals 1. Except this one is actually negative 5 to the 0. Anytime that they don't give you the negative inside the parentheses, you're going to want to assume that it's not attached. So this would actually be negative, and then the 5 to the 0 is 1. So our answer is negative 1, not 1. Okay, 7 to the negative 2 is using that negative exponent property, which says that I move it to the bottom of the fraction, so it's 1 over 7 squared. Please move it before you evaluate, right? Because this is the number. 7 squared is equal to 7 times 7, which is 1 over 49, right? But instead of changing it to 49 here, up here, and then thinking, I'll move it down, you're more likely to forget to do that second step, to move it down, if you do the exponent first. So first, make it positive, and then move it to the bottom of the fraction. So 16 times x to the 0 says 16, and there's no parentheses, but this is actually just x to the 0. So the common mistake we see is that people apply the 0 to the 16 also, and that is not what this says. In order for the whole thing to be to the 0 power, it would have to be written like 16x to the 0. This answer would be equal to 1. this answer, 16 times x to the 0, the x to the 0 is equal to 1 times 16 equals 16. That's the answer to this one. So please make sure that you pay attention to that, what actually has the exponent on it, okay? -2 to the 4th power. This is another one that people get tripped up on. They think, oh, it's a negative, I need to move it down. Well, that's only true for negative exponents, not negative numbers, right? So this actually says -2 to the 4th, which is equal to a -2 times 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8, times another 2 is 16. So a -16 is the answer you're looking for there. And you have a calculator so you can plug it in. Don't be ashamed to use your calculator. Okay, so now looking at number 5, we're looking at multiplying and using exponents, right? So what I recommend is that you group the things that are the same together. So we're going to do 9 times -2, and I'm going to rewrite this as 9 times -2 times x cubed times x to the 7th times y to the 4th times y to the 5th. Hopefully those rules are pretty fresh. 9 times -2 gives me -18. X cubed times x to the 7th, same base, so the powers get added because we're multiplying in between, so we add x to the 10th. Y to the 4th times y to the 5th, same base again, so we add those powers. And that's about knowing those rules. Now, the thing is, you really need to know these rules inside and out, because when you get down to some of these harder problems, it gets very easy to get mixed up with the rules and which rule to apply and what rule means what. So please make sure you're paying attention to that. And you spend some time getting comfortable with these rules. So p times q to the 5th divided by p to the 9th over q cubed. So we have division, which was subtraction. Remember that any p or any letter that doesn't have a number written is automatically to the 1st power. The rule for division is subtraction, hopefully you're saying. So we're going to do 1 minus 9 and q to the 5th minus 3, okay? Because I did 1 minus 9, the same base, and then q to the 5 minus 3. P to the 1 minus 9 gives me p to the -8. Q to the 5 minus 3 is q squared. Now what I need you to remember is that when you do this subtraction, you have actually pulled it up to the numerator of the fraction. That being said, my answer should be q squared in the top, and the p to the 8th needs to move back to the bottom. And that would be your final answer. And if you look back in the original, you can see that the p, the bigger exponent, was in the denominator. So it makes sense that the p would be in the denominator. Same, the q bigger exponent was in the numerator, so that one should be in the numerator, and that's always true. Okay? All right, -7 r to the 4th, s to the 5th. So now this one is in parentheses, and then the whole thing is cubed, which means by definition, -7 r to the 4th, s to the 5th times -7 r to the 4th, s to the 5th times -7 r to the 4th, s to the 5th, right? That's how we would write that out using the definition. It means it's times itself this number of times. But instead of having to write that all out, you can just distribute your exponent in, right? So it gets distributed to each piece inside. So -7 cubed, r to the 4th cubed, s to the 5th cubed. Okay, so -7 cubed gives us a -343. This is -7 times -7 times -7. R to the 4th to the 3rd, right? So now this is a power raised to a power versus before we were multiplying 2 at the same base. This time it's saying r to the 4th cubed. And this is where we multiply. So we actually get r to the 12th. And then s to the 5th cubed gives me s to the 15, right? Again, you can use the rules, the definition of an exponent to figure out what the rules are. This one would be a little bit harder because they're bigger numbers, but it would be r to the 4th cubed, so the cube means r to the fourth times r to the fourth times r to the fourth. Each of these means 4 r's, 1, 2, 3, 4. If you did that for all three, how many r's do you wind up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could still figure out the rule even if you didn't remember that it was supposed to be multiplication in between. Okay, x squared over x to the negative 3 times x to the fourth. So now you have several rules being used at once, and you have a couple different options. If we were in class, I would say, what do you think we should do first? But since we're not, I'm just going to tell you that for me, I like to get a positive exponent. So this x cubed needs to move up to the numerator. So I have x squared times x cubed over x to the fourth. Now I'm going to combine. In the top, I'm multiplication, so hopefully you remember that rule is addition. So I get x to the fifth over x to the fourth. Now I do subtraction. 5 minus 4 gives me just x for my answer. Okay, so 9 takes it up another notch, right? It's a little bit more difficult. 2x to the negative 1, y to the negative 2, all to the negative 3, right? That's what the parentheses mean, that the whole numerator is to the negative 3 power, over 3x to the negative 1, y to the 3 squared. So now, instead of moving this and trying to maybe make it positive, I would distribute the exponents first. I find it's easier to distribute the exponents, get rid of that part, and then start trying to make things positive and evaluating and stuff like that. So first, in the numerator, we're going to distribute the negative 3 all the way through. So 2 to the negative 3 power. I'm not going to actually multiply because it's a negative exponent, so I should not evaluate until I get it to a positive exponent. X to the negative 1 raised to the negative 3. Right? And so remember, it's a power to a power. So what we actually get is negative 1 times negative 3, which gives us x to the positive 3. Y to the negative 2 times the negative 3, right? Y to the negative 2 raised up to the negative 3 means negative 2 times negative 3, which gives us y to the 6. All over. Now the square is getting distributed through to each of these. So it's 3 squared, right? X to the negative 1 raised to the second power, right? So we do negative 1 times 2, which is going to give us an x to the negative 2. And then y cubed times 2 gives us a y to the 6, right? I'm going to erase this. X to the negative 2. Now what I want to do is move my negative exponents. Whatever is still negative at this point, I want to move. So I have a 2 to the negative 3, only negative exponents, not negative numbers, and an x to the negative 2. So this one is going down, and this one is going up. That's the only things that are moving. Nothing else is moving. So I have x cubed, y to the 6th, x squared, right, because this negative 2 is moving up and becoming positive, over 3 squared, which is 9. I'm just going to go ahead and multiply that. 9 times 2 cubed times y to the 6th. Okay, and now I want to evaluate any exponents I can, which is the 2 to the 3. So I have x cubed, y to the 6th, x squared, over 9 times 2 to the 3 is 8, y to the 6th. Now I want to simplify, right? So you can see I have an x cubed times an x squared. So those two are going to be x cubed times x squared, which is addition. So it gives us x to the 6th. Agree? Y to the 6th over y to the 6th is anything over itself is equal to 1. So those cancel out. Over 9 times 8 is 72. So the answer to this one ends up being x to the 6th over 72. Okay, so looking at number 10, it says 4x to the negative 2 times y over x to the negative 5th cubed. The whole thing is cubed. See, that's the big parentheses. That means the whole thing. So this 3 gets distributed into everything that's here. 4 cubed times x to the negative 2 cubed y cubed over x to the negative 5th cubed. Again, I would distribute the exponent before I started moving things. So 4 cubed is 4 times 4, which is 16 times 4, right? So 64, x to the negative 2 cubed gives me x to the negative 6, because I multiply exponents. Y to the 1 raised to the 3 is y cubed, over x to the negative 5 cubed gives me x to the negative 15. Okay, so now I have two negatives, and I need to go ahead and move those. So I have 64 x to the 15, because this one needs to move up and this one needs to move down. Some people might like to try to go ahead and subtract since they're the same base. If you feel comfortable with that and you think you can do that without making a mistake, that is okay. Okay, so y cubed over x to the 6th. Now I have 15 minus 6, right? Because I have x to the 15 minus 6. Those are the same base. So I should do subtraction there. Which gives me x to the 9. So my answer is 64 x to the 9th power y cubed. Okay, so looking at 11, says negative 3m to the negative 1, m cubed squared. So if you see, this square here is only attached to this m to the 3rd. These two don't have anything extra happening. So I'm just going to rewrite negative 3 m to the negative 1. M cubed squared is multiplication, so I get m to the 6th. Now here again, you could make it positive. So we're going to take our m to the negative 1 and move it down. So I get negative 3 m to the 6th divided by m. And then I'm going to subtract 6 minus 1 gives me a negative 3m to the 5th. You could do this up here and do m to the negative 1 plus 6 because it's addition in between multiplication, which would also give you m to the 5th if you wanted to. If you like this way better, that's okay, but you don't have to. If you're better getting positive and then simplifying, that is okay also. Okay, so looking at 12, we have m cubed over 8n raised to the negative 2 power. So now we can distribute our negative exponent into both of these, right? Which gives me m cubed to the negative 2 divided by 8 to the negative 2, n to the negative 2. Again, please don't evaluate a negative exponent. So what I'm saying is don't make this 64 here because you may forget to move it. More often than not, my students forget to move it. And then they get it wrong because they have it in the wrong spot. So instead, let's move it first. So we get 8 squared, right? And then we still have our m cubed to the negative 2 over n to the negative 2. Okay? So 8 squared. M cubed to the negative 2 gives me m to the negative 6 over n to the negative 2. And now both of these two are also going to move. So you could have waited to move it, but I just find that a lot of my students forget this step and then they miss it or they get it completely wrong because they made a mistake. So please be aware of that. So now I have 64 n squared over m to the 6th. And that's it for that one. Okay, so the last one, 13, has 81 c to the 6th, d to the 4th raised to the 5th power, c squared, all over negative 3, c to the 4th, d cubed raised to the 4th power. Okay, so we need to first start with your exponents, right? So I'm going to start here with this d to the 4th. I'm going to write everything else on the top. 81 c to the 6th, d to the 4th raised to the 5th power gives me d to the 20th power. c squared, right? And then this fourth is actually to everything that's in the parentheses, so it's distributing through to all of them. Negative 3 to the fourth, because the negative was inside the parentheses, c to the fourth raised to the fourth, d cubed raised to the fourth. Okay? I'm going to move on the top my c's next to each other. So 81 c to the sixth c squared d 20. Okay? Negative 3 to the fourth power is a negative 81. C to the fourth power raised to the fourth power is multiplication. So c to the 16. D to the third power raised to the fourth power, also multiplication. So d to the 12th power. Okay? Next step I'm going to do is combine these two c's in my numerator. So I have 81. C to the sixth times c to the squared is multiplication, so we want to add. So we get c to the eighth, d20, all over negative 81, c to the 16, d to the 12th. Okay, so now with exponents we would subtract, right? So I want you to look at 81 over negative 81. What does anything over itself equal? 1. Hopefully you said. Since it's a negative 81, we're actually looking at a negative 1. Then we have c to the 8th over c to the 16th, so it's c to the 8th minus 16, d to the 20 minus 12. Okay? The negative 1, c to the negative 8, d to the positive 8. Right? Now I need to move my c to the negative 8 to the bottom because we bring it up to the numerator in order to do the subtraction. So my final answer is negative d to the 8th over c to the 8th. You could write the 1, but we generally don't write it. Please remember that wherever the higher power is to start with, that's where your answer should end up. So c for my c's, I have c to the 16 in the denominator. So my c should end up in the denominator. And my d's, I have d to the 20, which is the bigger power. So my d should end up in the numerator. So please make sure you're paying attention to that for another check.